In this video, we're going to be taking a look at CAPE 2024, Unit 1, Pure Maths, Question 1. Part A reads, given that f of x is equal to 4 over x minus 5 and g of x is equal to 1 over x, we must find the domain of the composite function f of g of x. First thing that we should do is we should just find out what f of g of x is. So f of x is equal to 4 over x minus 5, and g of x is equal to 1 over x. To find what f of g of x is, basically, wherever I see an x in the expression for f of x, I just put g of x. So there's an x minus 5 in the denominator, so it just becomes a g of x minus 5. And now what's g of x? G of x is 1 over x. So I just put that in. Now I have to simplify. I use a little bit of algebra to simplify because it's a little bit complicated. So I'm going to multiply both the numerator and denominator by x. That's equal to 4x over 1 minus 5x. So that's an expression for my composite function f of g of x. We're asked to find the domain. First thing that we should do is remind ourselves what's the domain. The domain is the set of x values for which the function is defined. And the most important thing that you need to keep in mind for domain questions is just you have to make sure that the denominator is not equal to 0. Or if you have a square root, the thing that's inside the square root has to be greater than or equal to 0. So for here, the denominator is 1 minus 5x. So if I solve 1 minus 5x equals 0, I get x is equal to 1 over 5. So my domain is basically everything except 1 over 5. So I can write this as the domain of the function being the set of x in a set of real numbers x, that's what this means, such that x is not equal to 1 over 5. This is the domain of my function f of g of x. Okay, now let's do part B. Part B is a modulus inequality. It says we have to solve the inequality minus 3 times the absolute value of 2x minus 5 plus 2 is greater than or equal to minus 4. First thing that you should do, the first thing I like to do, is isolate for the modulus in an inequality like this. So if I do that, the first thing I'll do is I'll subtract 2 from both sides. So 3 times the absolute value of 2x plus 5, 2x minus 5, sorry, is greater than or equal to minus 6. The next thing that I want to do is I want to divide by minus 3. But we have to be really careful when we're doing this for inequality questions, because when you divide by a negative, you always have to flip the sign. So I do that. I just make sure and I flip the sign. So I get absolute value of 2x minus 5 is less than or equal to 2. That's my inequality. Now, there are two ways that you can branch off when you reach this point. One thing that you can do, which is perfectly valid, is that you can square both sides of this. And when you square it, removes the modulus and then solve the resulting quadratic inequality. That's one thing you can do. But the way that I'll do it is I'll say, okay, if the modulus is less than or equal to 2, that's the same thing as saying that 2x minus 5 is less than or equal to 2, and it's also greater than or equal to minus 2. And if I do that, I just add 5 to both sides. So I got 3 is less than or equal to 2x, less than or equal to 7, or 3 over 2 less than or equal to x, less than or equal to 7 over 2. I'd also like to just show that if we were to do the quadratic method, we're going to get the same answer. So let's just do that, right? So I'm going to start from here, and if I square both sides, I'm going to get 2x minus 5 squared is less than or equal to 4. If I expand this, I'm going to get 4x squared minus 20x plus 25 is less than or equal to 4, or 4x squared minus 20x plus 21 is less than or equal to 0. And if I factorize this, I get 2x minus 3 times 2x minus 7 is less than or equal to 0. So the two roots are at 3 over 2 and 7 over 2. But the important thing is that this is a minimum quadratic curve. It points up, which means it looks something like this. The first root is 3 over 2, and the second root is 7 over 2. And the region that we're asked to find is where it's less than or equal to 0. So it has to be here. In other words, it has to be x being greater than or equal to 3 over 2, but also less than or equal to 7 over 2. And that's exactly the answer that we got via the other method. So both of them are exactly the same. Whichever you prefer, it's up to you. Let's now do part C. This asks us to solve a logarithmic equation, log base 5x minus 4 log base x5 is equal to minus 3. The first thing that you should do with a log equation is you should make sure that all of the bases are the same. And as you can see in this one, they're not the same. So we have to apply a log change of base formula. And The easiest thing to do is to make everything log base 5. So what I'd have to do is I'd have to change the base of log base x5. So that's equal to log base 5 over log base 5x. And what's log base 5? Log base 5 is always 1. In other words, if you take the log of whatever the base is, it's always 1. This is 1 over log base 5x. So now if I substitute that into my equation, I'm going to get log base 5x minus 4 over log base 5x is equal to minus 3. Now let's let y equal log base 5x. So I get y minus 4 over y is equal to minus 3. Or if I multiply by y squared plus 3y minus 4 equals 0. In other words, you can factorize this as y minus y plus 4 times y minus 1 equals 0, or y is equal to minus 4 and y is equal to 1. But we're asked to solve for x. So this is saying log base 5x is equal to minus 4, or log base 5x is equal to 1. And now we just have to undo what log means. This means that just basically take 5 to the power of both sides, and you get x is equal to 5 to the minus 4, or x is equal to 5 to the 1. Well, 5 to the 1 is just 5. You can put this in your calculator. This is just 1 over 625. If you have some extra time in the exam, I highly suggest using this value of x and just checking and making sure that this equation is indeed true. And you'll see that it is. But I mean, that's just like one way to double check rather than just going over all the steps that you did. Because I have found, like, if I just go over all the steps that I do, it's very likely that I overlook the mistake that like if I was to make a mistake, it's very likely that I overlook it because I'm just kind of trusting myself. So it's like, if you do something slightly different to check over, it'll help to help you figure out if you made any errors. Okay, now let's do the last part. It says, prove that the function f of x is equal to 3x minus 2 is bijective. Once again, there are two ways that you can do this. One thing you can do is you can show that the function is injective, and then that it's surjective. And any function that's both injective and surjective is automatically bijective. Another thing that you can do is you can find the inverse, because any function that has an inverse is automatically bijective. So let's do that. The way to find an inverse is I'm going to first start with the function y is equal to 3x minus 2. Then I switch x and y. X is equal to 3y minus 2. And now I have to solve for y. X plus 2 is equal to 3y. Y is equal to x plus 2 over 3. And when I do this, this is equal to f inverse of x. So f inverse of x is equal to x plus 2 over 3. And since f inverse of x exists, f of x is bijective. Bijective. And that's all we had to do for this question.